Good day from NASA's Johnson Space Center. This is Mission Control Houston. The International Space Station Flight Control Team is watching over all of the systems aboard the space station. This view from the back of the room looking forward at the forward screens providing data to the team here in Mission Control as it watches over the station, which currently is orbiting the Earth at an altitude of 260 miles, having just moved into an orbital sunset, traveling northeasterly across the Indian Ocean. The next coastal crossing will be the islands associated with Indonesia here in just about 15 minutes or so. At present, the station is orbiting at that altitude, and the Cygnus cargo vehicle on its way to the space station is in a little bit lower altitude, continuing its chase to catch up with the space station. As of a little bit earlier this morning, Cygnus was 1,200 miles behind the International Space Station, closing in at a rate of about 82 statute miles every orbit, or every 92 minutes or so. All continuing to go very smoothly aboard Cygnus and aboard the International Space Station, which of course is occupied by the Expedition 37 crew, 3 crew members. U.S. astronaut Karen Nyberg on her second voyage into space, serving as a flight engineer of Expedition 37, along with Commander Fyodor Yurchikhin, Russian cosmonaut, on his 4th mission into space, 3rd long-duration flight. He also served on a shuttle flight as well. And of course, Luca Parmitano, European Space Agency astronaut representing the Italian Space Agency. He too is a flight engineer aboard the complex. And those 3 make up the Expedition 37 crew. 3 additional crew members are in final preparations with less than a week to go before their voyage to the International Space Station. Michael Hopkins, U.S. astronaut, Oleg Kotov, and Sergei Ryazanskiy, the Russian cosmonauts that make up the additional crew members of Expedition 37, are continuing their final days of training and refresher on their flight plan for their 6-month voyage to the station. They plan to launch next Wednesday, September 25th, with their launch time currently targeted for 3:58 in the afternoon U.S. Central Time aboard their Soyuz TMA-10M launch vehicle. The Expedition 37 crew on this Friday, September 20th, woke up at 1 a.m. Central Time, their standard routine early morning chores before they took some early human research samples, urine samples, and blood samples. Those have been stowed inside a high-tech freezer aboard the station for later investigation and research by investigators on the ground to help understand how the human body in different crew members adapts to the weightless environment of space, in particular with these periodic sample and data takes over long periods of time. The focus mainly today is on the human research facility, taking these urine and blood samples throughout several periods of the day, and also some routine maintenance chores as well. Crew members also earlier performed a onboard training for the arrival of the Cygnus cargo vehicle. The Cygnus, of course, launched from the Wallops Flight Facility on the eastern shore of Virginia from the Mid-Atlantic Regional Spaceport this past Wednesday. And so far, everything is looking very good with that Cygnus. Let's take a look at the Cygnus demonstration mission. This is the follow-on to the test flight back in April that proved the Antares rocket and its functions. This takes a look at the Cygnus spacecraft itself, which is on its way to the International Space Station with arrival set for Sunday morning.
With a half-century of spaceflight experience already in hand, America's space program is now pushing ahead on parallel paths, revolutionary and complementary paths. On one, NASA is building a space launch system and Orion spacecraft to carry astronauts farther from Earth than we've ever gone before, to an asteroid and eventually to Mars. On the other path, NASA is leaning on American-based private companies to help supply our orbiting laboratory, the International Space Station. As the Space Shuttle era came to a close, NASA knew it needed help to supply the station with tons of cargo every year and looked to the private sector.
How can we partner with industry? How can NASA be a partner with commercial industry and take advantage of the ingenuity and innovation that exists in American industry, as well as the entrepreneurial spirit to develop these new capabilities, just like any new product can be brought to market?
The answer was the Commercial Orbital Transportation Services program. Rather than NASA deciding on a spacecraft design down to the nuts and bolts, it made seed money available to private industry to develop their own cargo ships that could carry supplies to the space station, where human crews have been working for more than a dozen years. California-based SpaceX won its COTS agreement in 2006. Its Dragon spacecraft successfully performed a test flight in May 2012 and completed its first fully operational mission late in the year. SpaceX flights continue each year, taking tons of supplies and science up to the station, and just as importantly, returning science experiments back to Earth for study. Now, Virginia-based Orbital Sciences Corporation, which won its COTS agreement in 2008, is about to join the club with its Cygnus spacecraft. After Orbital performs a Cygnus test flight to the station, it too will begin flying routine delivery flights to the orbiting complex.
That will be the final milestone in what we call the Commercial Orbital Transportation System Space Act Agreement that will allow us to transition from that phase of the program into an actual contract with NASA to deliver cargo over 8 missions in about 4 years to the International Space Station.
Cygnus rides to orbit on the Antares, a 2-stage launch vehicle designed to provide reliable access to low Earth orbit for payloads of more than 5,000 kilograms. Its design incorporates components from leading global suppliers and uses subsystems that are already deployed successfully on Orbital's other rockets, the Pegasus, Taurus, and Minotaur launch vehicles that have been flying for years.
But Antares will serve a much broader market than just the space station logistics functions. It will also be used by civil and national security customers in the governmental market, as well as commercial satellite operators.
The Cygnus Advanced Maneuvering Spacecraft, consisting of a service module and a pressurized cargo module, also incorporates elements from flight-proven systems flown by Orbital and its partners. The service module avionics systems are from Orbital's LeoStar and GeoStar satellite lines. The propulsion and solar power systems from the GeoStar communications satellites. The pressurized cargo module is based on the multi-purpose logistics module by Thales Alenia Space, which built the cargo modules that carried supplies to the station 11 times, riding in the payload bay of the space shuttles. With a pressurized volume of nearly 19 cubic meters, Cygnus can deliver a total cargo mass of 2,000 kilograms.
Without the ability to take cargo, you won't be able to keep the station operating as a viable research platform, or even keep the crew there and keep them fed and clothed and all the things that anybody on an outpost would need. And that's really where they are, is on an outpost. So having that lifeline to Earth is very, very important.
Orbital will launch the Antares rocket and Cygnus cargo craft from NASA's Wallops Flight Facility in Virginia, thus opening a new commercial spaceport and strengthening the American commercial launch industry's role in the new future of spaceflight. As SpaceX and Orbital ramp up their supply flights, the International Space Station will continue to serve as our home in space and the site of the scientific discoveries that will allow humankind to venture beyond low Earth orbit, to explore farther from Earth than we've ever been before.
The Cygnus spacecraft, of course, launched Wednesday morning at 10:58 a.m. Eastern Time, 9:58 Central Time, and it's doing quite well on its way to the International Space Station. Some additional rendezvous maneuvers were performed on Thursday, and an additional 2 burns are scheduled for today. The next in the series of rendezvous maneuvers is about 3 hours away, with the next burn scheduled to be about a 56-second burn of velocity change of about 13.8 miles per hour. The burns are being adjusted just a little bit relative to the different launch time and some other items associated with just the normal orbital mechanics of the spacecraft relative to the ISS to tweak some of those numbers. This evening there is a planar maneuver basically to adjust its position, basically to position it just almost right in line with the orbit of the International Space Station. That planar maneuver scheduled to occur just before 8 p.m. Central and last about 35 seconds for a change of velocity of about 8 miles per hour. All of that's going to lead to an additional 4 very small tweaking burns that are scheduled for Saturday, setting the stage for the joint operations with the International Space Station, of course, beginning after midnight on Sunday morning. The data package review internally between the International Space Station program and Orbital Sciences is scheduled for later today. Essentially, that's a full-up health check briefing to the ISS program, and that will be prior to the go, no-go mission management team meeting that is scheduled for Saturday morning. All of that, of course, is ahead of the rendezvous and capture, which is still scheduled for Sunday morning, and we plan to cover all of that on NASA TV, of course, with our coverage at 3:30 in the morning Central, leading to the capture and installation of Cygnus on the Harmony module's nadir or Earth-facing port. And you see the times for all of that coverage, and after all that's completed, Cygnus will be safely attached to the station ahead of a post-capture and berthing news conference that you see scheduled tentatively for noon Central Sunday, 1 p.m. Eastern Time. In and around that, this shows you the animation of the post-launch and the coast period after launch when Cygnus became active. Those solar arrays were deployed within about a half an hour or so after the actual liftoff, which sets the stage for the rendezvous. You saw the profile that leads to a capture of the cargo vessel by the station's robotic arm. That Luca Parmitano will be the lead robotics officer on board the station to attach Cygnus to the ISS Harmony nadir port. In and around all of the preparations for Cygnus's arrival and also the arrival of the next 3 crew members of the station. The crew obviously continues in its science investigations on board. That's the primary reason, of course, for the International Space Station, with 3 major laboratories that make up part of the overall pressurized volume of the complex. The station, of course, has the Destiny Laboratory, the first laboratory that became part of the complex, the U.S. laboratory, and then after Harmony was attached to the station, providing additional docking ports, the European Space Agency's Columbus laboratory was added, and then the Japanese Kibo laboratory was added as well. So those 3 laboratories are providing nearly continuous science, even when the crew members do not have to interact with experiments on board, providing data. They do data checks periodically as well. But the focus of attention for science aboard the International Space Station is from NASA's Marshall Space Flight Center in Huntsville, Alabama. And standing by there is Lori Meggs, and she has an update for us. Lori, you have some results on some exercise experiments on board, huh?
That's right. Do we run differently in space than we do on Earth? Well, the answer may surprise you. A study called Treadmill Kinematics looked into how astronauts run on a treadmill on the space station. I recently spoke with a principal investigator to learn more.
The idea behind the study was to collect motion capture and ground reaction force data from astronauts as they exercise on the space station in order for us to be able to quantify these and then compare those motions to how they're performed on Earth.
So how did it actually work on station?
It was very simple, actually. All we wanted to do was capture data during an actual exercise session for the astronauts. We collected data 6 times from each of our subjects, and essentially all they did was place a video camera up to view the side while they performed their exercise. And the treadmill that's on the space station automatically captures the ground reaction force data. So we would downlink the video data, downlink the ground reaction force data, and then we would start computing what the peak forces were and what the joint motion patterns were. So it's very straightforward.
How many subjects did you end up with?
We had 8 subjects, 7 males and 1 female.
So tell me, do we have results yet?
We do have results. There's a couple things that are very interesting. First is that the running style or the running motion that we use in space is pretty much the exact same running motion that we use on the ground. So people run in 0 gravity the same as they run in 1 gravity, even though they have to wear a harness and a bungee that connects them to the floor. And on the surface, that may be a so what. Well, there's a big so what. First of all, the exercise that they do on Earth, we can say that the way they're going to move in space is going to be the same, so we can start to have better confidence that the way we exercise or the way we prescribe our exercise on Earth would be the same as in space. But more importantly, and this is where motor control experts may be interested, we have things in our body that we use for control, such as the otoliths that rely on gravity. These data suggest that either when we're in 0 gravity, we turn that information off, or we override it, so it's not an important control mechanism. And I think for people studying how the brain works and how the brain controls motion, this is a really big study or a really big result. Because in the past, most of these studies where people have tried to look at how gravity affects motion have really been focusing on smaller motions like reaching and grabbing something. And this is the only time that we have a large-scale amount of data with a pretty large motion like running, where you got multiple joints moving very quickly. To me, it was pretty amazing that the people pretty much run the same exact way in space as they do on the ground.
What are the Earth applications for this experiment?
We had to collect some pretty sophisticated data in a very difficult location, and we developed some ways using single camera video and then being able to convert that data into the coordinates that we could compute joint angles with. These are techniques that could be used by practitioners in any area where they can't afford, or they can't bring a $100,000 motion capture system to where they're doing their data collection. They could do what we did for sports or for rehab or anything like that. So we've developed some methodologies that could be useful for people on the ground.
Anything else you want to say about it?
Yeah, the ground reaction force data, that's the other part. This is what's really important for the exercise efficiency. What we find is that the exercise forces that you get in 0G are much less than in 1G, but they increase with speed. So what we want and would like our astronauts to do is run faster. If we can have faster running, maybe they do interval training where they run fast and rest and run fast and rest, they can get a better response for their bone growth than if they run a slower speed for a longer period of time.
What's the reaction to that when you tell an astronaut, run faster?
Some of them, they think that's great because they're runners. Some of them maybe aren't so excited because that's not their favorite sort of exercise. But we're hoping that we can show these data to the astronauts now. So instead of us just saying run faster because we think it's good, we can show them run faster because we know it's good.
And if you'd like to find out more about this and other human research investigations, go to nasa.gov/station. We have an astronaut there at the helm today, Payload Operations Director TJ Creamer, directing the team of flight controllers here, busy at work on a Friday. Back to you all at Mission Control in Houston, Kyle.
Thanks, Lori. That was very interesting, and She mentioned T.J. Creamer. He was a member of Expedition 23 back in December. He flew from December of '09 to June of 2010. So no stranger to life aboard the station, and now serving there in the Payload Operations Integration Center at Marshall Space Flight Center as payload director. Obviously, exercise one of the major items of attention aboard the station, as crew members need to maintain their cardiovascular and musculoskeletal systems through a varying degree of exercise equipment on board the station, including treadmill, as you heard there, and resistive exercise device for muscle training as well, and maintaining musculoskeletal systems as well. Crew members are allotted about an hour twice a day for exercise on the station to help maintain their systems throughout their stay in space, and also to help them recover more quickly once they return to the one gravity environment of that we feel here on Earth. The team of flight controllers here in Mission Control operate around the clock, 365 days a year on 3 shifts. The team currently on console is under direction of Flight Director Mike Lammers. He's been on since early this morning, and for most of the week actually on this shift. He is joined by Leslie Ringo to his right, who is serving as the voice interface between this team here in the control center and the crew on board the International Space Station. The systems of the ISS are in excellent shape, supporting crew activities. The crew held an early morning, what's known as a daily planning conference, talking with all of the flight control teams around the world that support the space station program. And they'll have another one at the close of their day later in the afternoon, just before 2 o'clock Central, and then after that, they're pretty much on their own time for their evening on board before they head to bed around 4:30. Their wake and sleep cycle is pretty much standard on board the station, and unless there are some specific activities that require different times and crew sleep adjustments. But their cycle is pretty much straightforward right now, with the Cygnus spacecraft arrival at the International Space Station scheduled for Sunday morning. All of the major rendezvous activities will occur overnight, with the actual capture targeted right now for just before 6:30 in the morning Central Time, 7:30 Eastern Time. The focus of attention for Cygnus after its launch from the Mid-Atlantic Regional Spaceport there at Wallops Flight Facility on the eastern shore of Virginia, after it was safely delivered to orbit, switched to the Cygnus Control Center, which is at Orbital Sciences headquarters there outside Washington, D.C. In the Dulles, Virginia area. And we're fortunate to have Bruce Manners with us, joining us from Dulles, from the orbital location. He's the project executive for NASA's Commercial Orbital Transportation Services program. And Bruce, are you there? It's great to have you with us today.
Yes, I am. I'm really glad to be here.
I bet you are. I tell you, I was on console for the launch, and the Antares obviously did its job putting Cygnus into orbit, and I guess that just started the work day for all the orbital folks and the NASA folks that are supporting there at Dulles.
Yes, it did. It was a beautiful launch. I was actually privileged to be at the Range Control Center at Wallops for the launch, and was able to see that and the data, launch the data and all that firsthand. And it was just an exciting moment. But as you said, it was really just the beginning. Once the Antares rocket left the spacecraft on orbit, focus really shifted over here to Dulles in Virginia, where the flight control team for the Cygnus spacecraft took over.
And I've been reporting each day a little bit about the progress and the health of the spacecraft, but maybe you can go into some more detail, I guess, about after we went off the air Wednesday. Obviously, the solar arrays were out, the vehicle was healthy, but talk about what's kind of been the progress since Wednesday, and set the stage for Sunday.
Sure. Well, the vehicle is in great shape. I really couldn't be happier with how things are operating there. They have, at this point, completed a couple of their demonstration objectives that they need to accomplish before they get approved to come into the station. That data right now is really still in review with all of the flight control teams back in Houston and in Dulles, but the preliminary looks at all the data says that everything's going great. They were able to maintain position and attitude control and free drift when told to and when commanded to. So that's all great news. What's really been happening since then, as you said, they have the solar arrays out, and the spacecraft is fully powered. They've checked out all the systems, and everything seems to be running really great. So really the big movements right now is just chasing after the space station, doing delta V burns, and trying to get themselves into the proper position to, once they get the authorization from Houston to come into the station. So that's really been the focus of the activities, checking out that vehicle, getting those first couple of demonstrations done, and chasing the station.
So, so that leads us to Sunday morning, obviously, for the rendezvous. Everything starts happening about 1:30 in the morning, I guess, your time there on Eastern time, 12:30 here. But one of the first call-outs, I guess, that morning is the go, no-go decision for joint operations, and then from there on, kind of the rest of the, it's a pretty feverish pace, I guess, in orbital mechanics lingo. But describe to us kind of what's going to happen on Sunday.
Well, I'll do the best I can. It's not really the best one for all the orbital mechanics pieces of it. The mission flight teams are, I'm sure, much more equipped to handle those kinds of questions. But as they come into the station, they will have to still have some demonstration pieces that they need to sort out until they can get close enough and ultimately captured by the robotic arm. It will be operated, of course, by the onboard crew in the International Space Station. That capture point, once they've been able to grab a hold of them, that's referred to as capture, and then they will berth them all the way into the space station, where then we've got pieces then that the crew will have to more or less bolt the vehicle into the space station before they'll be able to ultimately open the hatch, which will hopefully happen in a day or so after that.
In this flight, it's called a demo flight, but obviously with everything going very smoothly, I mean, all the orbital folks, NASA, obviously you guys have to be really thrilled with the performance of this vehicle so far. But now you look to the next flight, which I guess is known essentially as the real first cargo delivery flight. But and I understand preparations are probably already underway to reach a goal of trying to launch that flight maybe as early as December.
Yes, sir. They do have cargo on this flight. There is a little over 700 kilograms of cargo on this flight. But the intent here was to keep that really sort of low-value pieces just in case there was any issues. But right now, of course, it looks like we are absolutely on track to be able to deliver that cargo to the station, and it has some student payloads and then some pieces for the crew themselves and things, all that. But yeah, there is work well underway for the first operational flight under the CRS contract. We do hope that can possibly happen in December, maybe not until January. That schedule needs to get sorted out at this point. But if you were to go to the horizontal integration facility at Wallops, you will see all the pieces really coming together for the next Antares. And in H100 at Wallops, they also have the next PCM, the pressurized cargo module, the service modules. It's all really starting to come together. And you can see the pieces, and the crank is beginning to turn to really see it in a production line mode, so they can keep churning these things out every 6 months or so. But we're really excited about this mission right now. But if you look in the history where we are, this is really you could think of it as the third flight of Antares in the last 7 or 8 months. They had a hot fire test that was done back early this year. Then, of course, the Antares flight in April, and then this flight with Antares and Cygnus again now. They've really done an awful lot, but you can see that the production line mentality is setting in, and so they can churn those things out and get them out as quickly and as often as we need them.
Yeah, that sounds great. It's nice to have a vehicle that is probably well ahead of its processing, and all it has to do is wait for a little bit of highway traffic around the station, and it's always nice to have a busy highway around the ISS.
Absolutely. We get this mission. We will deliver the cargo up there. We'll take some trash away when they leave in 30 days, and then, as you said, they're rapidly trying to get everything wrapped up and buttoned up for the next mission, which hopefully we can do as early as December, but if not, maybe into January. But the hardware is definitely coming together.
Well, obviously, give all of our best to the orbital team and obviously the NASA folks supporting all the activities up there at Dulles. We'll obviously be here supporting as well and watching along, and we really appreciate you, Bruce, stopping by and talking with us today.
Thank you very much, and you folks have a great day, and let's go Cygnus. Looking forward to the birthday on Sunday.
Take care. Thanks, Bruce.
Thank you.
That's Bruce Manners. He's the project executive for NASA's Commercial Orbital Transportation Services Program, the COTS program. As you heard Bruce mention, some of the data pack review, that the data is essentially that which streams down from Cygnus and is put together by that team and presented to the NASA station team as well, including the mission operations team that supports all of the activities associated with this particular visiting vehicle. As obviously, again, there's a full-up review of all of that data later this afternoon, Friday afternoon, and that will be ahead of the presentation Saturday morning to the mission management team for the ISS. That officially will give the go, no-go, or make the go, no-go decision and poll for the formal rendezvous and capture activities, which are scheduled to commence with the joint targeting reference arrival point scheduled for just before or just after 2 a.m. Sunday. That will be preceded by a go, no-go for joint operations by the flight control team here in Houston. The lead flight director for the Cygnus demo mission is Courtney McMillan, and she is currently overseeing the Orbit 1 team, which is the flight control team shift that precedes the one that's on console right now that Mike Lammers is overseeing. So as you heard Bruce Manners mention, the Cygnus is in excellent shape, and everybody at Orbital and obviously at NASA very thrilled with the performance of the spacecraft thus far, with obviously quite a ways to go with some additional rendezvous maneuvers, but with a healthy spacecraft after its Wednesday delivery to orbit atop the Antares rocket, and another Antares and Cygnus in processing at Wallops for the next flight to the station. All's going very smoothly. This is Mission Control Houston here in the International Space Station Flight Control Room. A team of flight controllers is watching over systems aboard the orbiting complex with Expedition 37 crew on board as they await the September 25th launch and arrival of 3 new crew members to augment their own crew. Fyodor Yurchikhin, Luca Parmitano, and Karen Nyberg practiced robotics ahead of their new cargo spacecraft, the G. David Low Cygnus, which is scheduled to arrive early Sunday morning with 1,300 pounds of cargo. Following its launch Wednesday morning from the Mid-Atlantic Regional Spaceport at NASA's Wallops Flight Facility along the eastern shore of Virginia, the Cygnus has performed near flawlessly in its checkouts and maneuvers en route to the station. The rendezvous activities begin early Sunday, and NASA TV will cover the final hours of approach, grapple, and berthing to the station's Harmony Node 2 Earth-facing docking port. This week, Parmitano, who will operate the Canadarm2 robotic arm from the cupola, and Nyberg trained and refreshed on all the procedures ahead of the capture, which will occur once Cygnus is within reach at a distance of 35 feet. Cygnus represents the culmination of many years of work to supplement the cargo delivery capability to the station with commercial customers, and with Arrival Orbital Sciences Corporation will join SpaceX along with Russia's Progress, European Space Agency's ATV, and Japan's HTV in maintaining the outpost with supplies, hardware, experiments, and logistics on a consistent basis. The launch from Virginia was the first station U.S. mission beginning from a location other than Florida. The 3 crew members on board also are eagerly anticipating the arrival of the Expedition 37 and 38 crew, which now is at the Baikonur Cosmodrome in Kazakhstan awaiting their launch next Wednesday, September 25th. Oleg Kotov, Sergei Ryazansky, and Michael Hopkins launch at 3:58 p.m. Central Time and arrive 4 orbits later at about 9:48 p.m. With everything else going on, the crew also conducted science investigations focusing on human research. Nyberg and Parmitano served as doctor and patient, gathering urine and blood samples for preservation in the high-tech freezer on board for later analysis by investigators on the ground to help understand how different crew members adapt to space travel over long periods. The two also performed eye exams on each other to measure any changes that may occur in eye pressure and visual acuity. The crew will set up cameras and equipment needed in the robotic workstation ahead of Sunday's Cygnus arrival and have some off-duty time Saturday before Sunday's full day supporting the cargo vehicle's arrival following its launch atop an Antares rocket Wednesday. Next week, the crew will spend a good deal of time unloading Cygnus and continuing science investigations. As mentioned, the new 3 crew members are getting ready to launch from Baikonur. Let's take an opportunity to meet these 3 crew members that will be headed to the International Space Station next week.
Aiding the pursuit of knowledge is a top goal for the 3 newest members of the International Space Station's Expedition 37 crew. Dr. Oleg Kotov is a native of Simferopol in what is now Ukraine. But as the son of a Soviet military officer, he grew up all over Russia and had his sights set on the military for his own career by the time he finished high school in Moscow.
I decided to become a military officer as well, like my father, my grandfather. However, I kept dreaming about space, and while I had to select my major, I was very careful about it, and I became a military surgeon in the area of aerospace medicine.
After graduation from the Kirov Military Medical Academy, Kotov went to work at the Gagarin Cosmonaut Training Center as a doctor, studying altitude physiology and the effects of spaceflight on the human body. At the same time, he studied diagnostics and methods of pilot selection and also earned a degree in patenting. In 1996, he entered Air Force pilot school and was selected for cosmonaut training. He made his first spaceflight in 2007 and completed 2 spacewalks as a flight engineer on Expedition 15. He did another EVA during Expedition 22 before becoming commander of the station for Expedition 23 in 2010. Kotov then served as deputy chief of the GCTC before starting training for this mission, which presented another opportunity to fulfill the human instinct to learn new things.
It's a desire to understand the world around you, to expand the area where we live, to explore the space, Mars, Moon, other star systems. So it's a question about a desire to learn something new.
Dr. Sergei Ryazanskiy is a rarity among Russian cosmonauts, one who was born and raised in Moscow. As the son of engineers and a grandson of Mikhail Ryazanskiy, a leading Soviet engineer specializing in missile and spacecraft radio guidance, Ryazanskiy had his sights set on a career in science at a young age.
When I was a child, I wanted to become a biologist. So I was studying in a specialized school where we were majoring in biology, so I knew that I would be a scientist. I think I knew that since I was in the 6th grade. I knew that I would try to go to the Moscow State Universities,
where he graduated with a degree in biochemistry and went straight to work at the Institute for Biomedical Problems at the Russian Academy of Sciences. His specialization in ways to prevent the adverse effects caused by the absence of gravity got him involved in the space industry and sparked an interest in becoming a cosmonaut himself. In 2003, he was selected to join IBMP's Cosmonaut Corps and completed basic training at the Gagarin Cosmonaut Training Center. In 2006, he earned his doctorate in physiology and space medicine. And in 2009, he was crew commander in a 105-day-long isolation experiment known as Mars 500. By 2010, he was certified as a GCTC test cosmonaut, which he calls the most interesting job in the world because it combines so many things.
Anything you can think of is combined by this profession. And being part of this industry is very interesting. You have new technologies, new approaches, and you're always on the edge, so to say. You always know the latest developments. It's very interesting to live this life. It's very interesting to train for this life. That's why I became cosmonaut.
U.S. Air Force Colonel Mike Hopkins is from South Central Missouri, born in Lebanon and raised a few miles away on a farm outside Richland. He credits his small-town upbringing for his getting the chance to try everything in high school, not only football and other sports, but all school activities, and for developing his interest in engineering.
My father was a pilot in the Marines back in the early 60s. He flew A4s, and so there was aviation in my family. So that certainly piqued my interest in it and my interest in space. My desire to become an astronaut started back in high school.
Hopkins headed to the University of Illinois to study aerospace engineering. He also walked on to the football team and ended up as a starter and a team captain by the time he graduated with his bachelor's in aerospace engineering and a commission in the Air Force earned through the ROTC. After finishing a master's in aerospace engineering at Stanford, Hopkins began his Air Force career in a laboratory working on space systems technologies. Then he moved on to become a flight test engineer, even spending time as an exchange officer at the Canadian Flight Test Center in Alberta. In 2002, Hopkins won a scholarship to study political science in Italy, after which he was assigned to work in acquisitions at the Pentagon, and then as a special assistant to the Vice Chairman of the Joint Chiefs of Staff, the job he had when he was selected as an astronaut in 2009. He's the first member of his astronaut class to fly in space, and eager to use his mission to try to help satisfy our desire to learn.
Humans are always striving for knowledge, for knowing what's beyond the hill, for knowing how each little thing works in our world. whether it's the human itself, whether it's anything within biology, the physical world, all of that, we have this desire to know as much as we can about that. And the space station, the International Space Station, fits right into that.
One of the other activities aboard the station that Hopkins is very interested in, and obviously keenly interested in, is exercise. And we have an opportunity to show you a short video of Hopkins and his exercise routine. And that's Michael Hopkins, his routine put into about a minute and a half, show how he is readying himself for his voyage to the International Space Station that begins with colleagues from the Russian Space Agency, cosmonauts Oleg Kotov and Sergei Ryazinsky, as they prepare for their launch next week. The rest of the cruise day will include some battery charging for some of their onboard tools that they use periodically, and they'll also have some afternoon exercise sessions before meeting with all of the flight control teams before going to sleep. They'll have a fairly quiet Saturday ahead of all of the activities on Sunday associated with the arrival of their newest cargo vehicle, the Cygnus, the G. David Lowe Cygnus spacecraft, which arrives with our coverage beginning at 3:30 Sunday morning, leading to the rendezvous, capture, and berthing of Cygnus to the Harmony Module's nadir port. You see the coverage times for that, so be sure to tune in on Sunday morning for our special coverage of the arrival of Cygnus. We'll wrap up our week of coverage of ISS Expedition 37 by showing you a new feature on the from the NASA Commercial Crew Program, which continues to build its momentum after beginning with artist concepts and designs. The spacecraft developers now are testing full-size models and taking steps to qualify subsystems. The agency's astronauts are already practicing launches and landings in simulators to iron out details in critical software. NASA and the Commercial Crew Program stand on a path right now leading to launch from American soil in 2017. Have a great weekend, everyone.
For more than 50 years, NASA has overcome the physics that bind us to Earth, lifting people off the planet to explore low Earth orbit, then safely returning them home. Today, astronauts live and work around the clock aboard the orbiting laboratory of the International Space Station, where NASA is gaining the knowledge it needs to send humans to an asteroid and then to Mars. As the agency sets its sights on exploration destinations farther into the solar system than ever before, a new era of commercial space is emerging in low Earth orbit. With the Commercial Crew Program, NASA's stepping back from directing the detailed development and operations of human space systems and letting our industry partners develop detailed new solutions to spaceflight while we ensure safety and performance requirements and offer guidance and expertise. Once these capabilities are matured, NASA could contract for transportation services to launch U.S. astronauts on American-made spacecraft to the space station once again from U.S. soil. NASA wants to contract the safest flight into low Earth orbit, but the agency doesn't necessarily need to own the spacecraft. After 4 years, the Commercial Crew Program is seeing tremendous progress from the American companies it has partnered with. Designs that were limited to the drawing board and artist concepts have turned into full-size models that are deep into testing. Astronauts already practice launch and landings in simulators to iron out fine details in critical software. Technicians and engineers regularly leave their desks behind to jump in a pool to evaluate their plans to recover astronauts and spacecraft following a water landing. Some of the most powerful thrusters envisioned for a spacecraft are undergoing test after test to prove the design will work. Wind tunnels across America are hosting heavily instrumented versions of rockets and spacecraft to prove they are safe and reliable for our astronauts to fly aboard. Although some of the spacecraft are familiar shapes and others appear radical in design, this is the first time NASA's explored the development of multiple spacecraft at the same time that are each designed to take astronauts into orbit. NASA's vast launch and spaceflight experience goes into each of these spacecraft, along with cutting-edge innovations from our industry partners. Commercial Crew Program's progress so far is the result of our diligent and relentless efforts to reshape the American spaceflight program. At NASA's Commercial Crew Program, we show every day the success that comes with taking a new path into orbit.